Within ASAP, we can define systems made of any type of optical material, including crystalline materials. We can also define our incident energy to have a particular polarization state, and we can then watch what happens to the polarization state and the electric field as the light propagates through that system. In this particular case, let's see what happens when light propagates through a sapphire dome. Sapphire is a crystalline or birefringent material, and we'll take a look at sending a wavefront through this crystalline dome and see what happens to the polarization state of the energy as well as the electric field. Okay, now let's take a look at what we see here. The first is our dome, and we can see the light coming into the sapphire dome, and we're watching the refraction of the ordinary rays as it propagates through. And what we've defined is an input circular polarization state. So before the light hits the sapphire, it has a circular polarization. And then as we look at the output, we see crossed linear polarization. Again, sapphire is a birefringent material. And we can look at the electric field behavior. And again, we see somewhat of a circular electric field, linear in some positions, as a function of the incident angle of the energy when it struck the dome. And this plot is a little bit more complicated to understand, but it's the same as the previous plot, except we're looking at it in 45-degree phase shifts. So there are actually 4 sets of data superposed on each other, showing us what happens to the electric state as the phase rotates through 45, 90, 135, and 180 degrees.